some of the stuff that was done last week, I believe, was around assignment to array to elements of arrays, i.e., the first kind of implementation of referenced data. So where the data isn't just bound to a variable, but it's within some kind of composite data structure. And so that was interesting. That involved having to wrap essentially all data in these arc mutexes. And yeah, I don't quite remember exactly where I left off last week, so I just need to double check what I was in the middle of. Did I do a branch at the end where I was refactoring something? I left that part way through because it was looking like slightly more effort than it's worth, but I don't think I'd actually moved on to any new features as such. So and then the last bit of where I was, yeah, so if I recall correctly, the code that I was working on in terms of the few snippets that I had shared online as an initial task, I believe I actually got through all of them. So so at this point in time, most of what I had, say, initially shared as objectives for the stream have more or less been complete now. So like from here on, it's basically just fleshing out a number of the remaining features. A lot of them can be seen in this to-do list, so such as destructured assignments using structs, which will involve, well, that would be involving objects, and actual implementation of objects. That'll be a big one to implement still as well. And there'll be a bunch of string operations, I believe, possibly Boolean operations. Looking at anonymous functions, what we have in terms of functions could probably be reused and just changed from being a function declaration to an express. I don't know. There are probably different approaches we can take here anyway, and then some built-ins that need to be implemented. So for the most part, yeah, it's probably like, it's probably at the point where a lot more has been implemented now than has left to be implemented. Actually, just looking at some of the built-in functions, one thing I wanted to do all right was refactor the function definition implementation slightly so that the interface is a bit more uniform. So what do I mean by that? It's just that, let me see here. So in the evaluation section, so if I go to eval, I think it's expression, and yes, expression call. And we basically have these two types. In fact, if I go down to the definition of a value, there are these two kind of competing definitions for what a function is, that we specifically keep separate the definition of a regular function and a built-in function. So one thing I'd like to do, and potentially now it would be a good time for doing that, is to unify those, and I'll probably have to, so if I open up main here, I'll probably have to unify them under the type for a built-in function. And so that would mean that a built-in function would be changed to just func. It would still be defined in terms of an actual Rust function. And then what we would do here is probably just wrap up this. So the way that this is evaluated will just be wrapped up in a function itself. So let me take a look at that quickly. So I'll undo the change there. Where is built-in func being used? Is that the only usage? Yeah. So it would mean that when we define a regular function or create a regular value func, that instead of just defining the statements and evaluating it later, the actual rules for, or the actual function for evaluating this will be stored instead. So let's take a look at, yeah, where a function gets defined. Yeah, so we create a value func here. So I'm actually going to use the built-in func value here and update this to be a function that can be evaluated. Now this will also need to be something that can, again, I don't remember the exact mechanisms of for example, fn once and the different function traits and how they differ from that kind of built-in syntax. So, you know, what's the difference between an fn trait and fn like this, an fn signature? But I suppose I'll just see what works and hope that what works is the correct thing to do. But so if I'm changing this to a built-in func that's going to be stored, yeah, then the value would be f. Can I do it like this, I wonder? Maybe I'll, so I suppose two things I could do here is maybe I could, I suppose one thing I can do is just put the evaluation here, but I could also put that in a new function called, for example, eval func, and it will be like this signature, but would also take the function definition. So maybe I'll start there. So if I have a function eval func, and so it would need, so those would be the arguments, and it will return that. It will also need the actual function definition and the context, or context being scopes. And let's do that. And then have a function definition there, and that would be more or less the things we have here. So or the old, yeah, in fact, that, whoops, where did I go there? What is currently called func, it would be probably called function definition now. And then let's see. Yeah, so I think that that makes sense. So we have a function definition here and a built-in function. When it's called, then we'll take, let's see, so we'll have let func definition will be like that. We'll get rid of those there, and then, whoops, built-in function will then take the arguments as, so this will need the regular signature, and then maybe I'll put that onto a new line just to make it a bit more readable, I think. And so then that function will just call a val func, whoops, not a val func, and we'll take the well, this will need to take a scope as well, actually, and so the built-in functions will need to be updated to take scopes too. So so we'll take scope stack there, and then when we're evaluating the func, we'll take the new scopes, we'll take the func definition, and we will take args. And we won't put a semicolon there because the value returned from a val func will, in fact, I'll take function definition as the first argument because function definition will be the same for each call, but scopes and args will change. So so the result then will, yeah, just be returned as normal, and that should be, that means that if we remove that type of value, we'll be using that to as our definition of a val func, and that'll mean that we can remove this this special handling of functions, and can I put all of these on one line? No, they're not going to fit. So that's okay. And let's see. So inner scope. What's closure? Oh, that doesn't sound good. I don't have that in my current scope. Oh, it's part of the function definition. Yes. So I would be doing something like let func defin and it would be args, arg names, statements, and closure. And how is closure working? Oh yeah, it's maintaining a reference to the scope at that time. So that will be decomposed or deconstructed. And then let's see. We now have closure, we have inner scope, we have statements. And then based on what is returned by evaluating the statements, it will either return an error, or it will return the actual return value, or null if there was no null, return value specified. So yeah, that is more or less the abstraction that I want to make, I think. And then I won't change this right now, but I'll be renaming that to just func once once the rest of the code is working. So yeah, I'll take a look at that now. Now, one thing that I'll definitely have to update in a second is I'll have to update built-in func to take this scopes parameter. Actually, how is it resolving the closure scope with the scope that's being passed in, actually? Oh wait, sure, there shouldn't be a scope being passed in, actually, after all, because yeah, it should be evaluated in the context of the scope it was defined in, rather than the scope that it's being called in. So I'll actually be removing that. That was silly of me. And then what else do I remove? I remove this guy here and that. So that makes things hopefully more correct. And so actually I don't need to change the existing built-in function definitions. So so yeah, that's more or less what I want in terms of in my head, what I'm thinking. But now I need to figure out how does that actually, what are the errors we encounter now? Because especially I'm not that great with these say more anonymous function type definitions and things like that. So I'll have to see, how's this all going to work, and how's that going to work with clones and things and closures. I'm not sure. So probably going to run into some issues with the borrow checker there, but hopefully those will all get resolved. So line 204, coming up to the first one, expected an expression here, but got an fn. How do I define these in main, actually, these built-in functions? Oh, I don't define them like that anyway. I just define them as regular functions and then just pass them in, because they don't actually take any like they don't have any closure, or the arguments to them don't change. What I could do potentially to make things easier on myself is I wonder if it would work to define a method on function definition to call the function, which would just be this. Could clean up the code, and it might make more sense, and it could just be a little easier on myself as well in terms of defining this and working around the borrow checker. So I think I'm going to do that. So if I go to, if I go to function definition and I implement it, but that's not going to have the signature that we want, will it? Because it'll have this self parameter, which I assume Rust is going to complain about. Perhaps. We'll take a look. I suppose I will just copy that. That's going to be, does it have to be mutable reference? I wonder. I'll see shortly. So I'll go self there. Get rid of eval func for the moment. Get rid of that too, and this would hopefully be simplified to something like func defin eval. That'd be cool if that worked as simply as that, but we shall see soon enough. So let's see. Method not a field. Attempt to take value of method eval on type function definition. Though that's kind of what I want. I was hoping that it would recognize that it's that's a method and be like, oh, that's a function, and this field is meant to hold a function. So let's just yeah, and I don't want to use parentheses called a method. So yeah, that's just not a runner. In that case, what do I want to do here? Maybe do I need to use the function traits in that case? Let's see. So could just keep the new setup because it looks kind of do I prefer that or the function based definition? It's kind of one and the same. I'll actually go back to eval func. And yeah, we'll do it like that. So let's see, line 204, expected expression, but got this thing. Yeah, that's not valid, it seems, and I assume I can't just put put a closure around it like that. If val func wasn't found, let's remedy that. Closures can only be coursed to fn types if they don't capture any variables. Yeah, so I'll have to use an fn trait, I assume. And is there any way of working around that? F would need to take the function definition as a parameter, but the evaluator would need that to be carried with the yeah, either the function definition can be carried within the function by having a closure closed over it, or else the function definition has to just be carried in the object the way we had it before. And like realistically, this isn't functionality that's essential. It was more just not even necessarily a nice to have either. It was just the way I want to hopefully do it. Yeah, I suppose I'll just take a look at you again using function traits to try and achieve this. But if it doesn't happen, then not the worst in the world. Still works without it. So let's take a look. So fn is implemented automatically by closures, which only take immutable references to captured variables. So the function definition should be an immutable reference, although the variables in its scope, are they still immutable references? I'm not sure, because if they're wrapped in arc mutexes, then there's fn mutable. Hello, Juan. Good to see you again. And fn once are super traits of fn. Any instance of fn can be used as a parameter where fn mut or fn once is expected. Use fn as a bound. Yeah, Rust is treating me well. For the most part, I'm playing around with the function stuff here. Kind of working with, say, anonymous functions and closures is probably a little trickier than what I'm used to, but yeah, it's not something that I've used too much, so it's it's relatively self-inflicted. So yeah, like it potentially isn't so complicated if you're very familiar with Rust lifetimes and things like that. But because I only use Rust kind of relatively sporadically, it means that I'm probably not as au fait with the whole setup of lifetimes and borrowing and things like that, as I probably should be for using a mechanism like that. But it's also one of these things that I probably should understand it a lot more, but a lot of the time, if I'm able to get it working such that, you know, the Rust checker is happy, then generally means that the program is working. But you know, that's not um, need to make a trait for each anonymous function. So it's not that you need to make a trait for each anonymous function, but there are potentially different traits that you need to satisfy in order to create an anonymous function. So just for context here, what what I'm trying to do here is abstract over um, the over function calls. So basically, I have these two. So in the definition of a value in this language, we have basically two types of functions. There's built-in functions, which are basically just anonymous wrappers around Rust functions that perform different utilities, such as printing a value. And then there's you know, function values, which are functions defined within the language. And I was thinking it would be kind of neat to just have one single definition of a function. And this would be the way to do it, really, is to, if I could wrap around the function evaluation that gets performed when I provide a function definition, then I could have all functions using basically the same signature. But that's where I'm running into the issues here is, first of all, this signature isn't valid for what I'm trying to do. What I'm trying to do here is basically create a closure over the function definition. So then the function definition itself doesn't need to be stored with the function. But actually, just talking about it out loud there now, like that's something that I could potentially do as well. Is I could bundle the function definition here, maybe, so that we have func defin, though like realistically none of this, again, I was mentioning earlier, none of this stuff is particularly essential. It's working without it. I was just seeing if I could do it kind of easily, but based on this so far, it's looking like it might be a little trickier than I necessarily want to go into in this session. And I might just kind of continue adding more features if this doesn't work out rather quickly. So it does have, well, I suppose, it's not that it doesn't necessarily have generics for anonymous functions. It's just that in order to use or store anonymous functions, I suppose, like everything in Rust, there's just rules on how you're meant to use them. So for example, if I want to store this anonymous function, I need to get the type signature right. And basically this, you know, this current type signature can only be used with function pointers, apparently. Now, if I change this, just based on what I've read just now, I can change this to a function trait, perhaps. In fact, no, I'd probably have to do something like this. Where f is an fn, something like this. Yeah, it's probably something a bit more complicated than I have to be honest, brain power to process right now. Yeah, it is a bit tricky, I have to admit. It probably makes, again, with all things in Rust, probably makes things a lot more explicit, and you've kind of more direct control or more insight into the, for example, mutability and reusability of all these anonymous functions, which again comes into play when dealing with lifetimes. But again, when you're only touching this kind of stuff, maybe once a week, you get a little out of practice, and need to brush up on exactly how this stuff works. So yeah, so if you do not need strict requirements, I'm thinking I might just use fn mute. Again, not fully sure what the difference is between fn mute and fn once, but it might get us past this hurdle. So let's see, 7 errors anyway. That's not off to a great start, but we'll see. Where's the top of these errors? So, okay, yeah, I'll then need to add generics for each add generic value for each usage of value. Yeah, that's probably not. How do I add this trait bound into value then? Maybe it would have to be something more like using dyn or something. Yeah, I'm probably opening up a big can of worms here that I'm probably better off researching a lot more before I do it in the middle of a stream. So, whoops. Expected reference found closure. Yeah, no, this this isn't happening today. I don't think this is a lot more complicated than I realistically want to get into. So what I'm actually going to do is take a look at what are the changes that I've made, and I'll probably just yeah, I'll probably just discard those those changes for the moment, and go back to where I was. Nim to make an anonymous function, you just remove the name and it's an anonymous function already. Python anonymous functions cannot be used for anything serious because they're single expression only. Yeah. Yeah, Python's what's it and so-called anonymous function. Well, no, they are anonymous functions, but yeah, they can only basically be a single line. They can be multiple lines, I suppose, if you use that backtick. But they are a serious limitation I found in Python, all right. Yeah, most languages would allow you to just kind of remove the name, and it's like, yeah, that's an anonymous function. It's a function without a name. But yeah, in fairness, I suppose Rust does do things kind of a lot more strictly. And there are probably other ways of doing what I wanted to do here as well. Again, I could, if I just wanted to have a single function definition here, I could have the sum type within the value as well. But it's just something to mess around with sometime. Anyway, just a bit of a derail to see if I could do something neat quickly, but that didn't work out so well. But I'm going to just jump back to the to-do list and see if there are any other, what are the next kind of few things that I want to knock out. The next big thing anyways is objects. That will be kind of, I would say, a sizable amount of work, but it's something that I'm very excited to have done. Again, there'll be a lot of design decisions to be made in here as well. Probably mostly along the lines of, how many of the mechanisms from JavaScript do I want to import into this language? But and do I want to put any extra rules on them? But for the most part, yeah, this is kind of one of the more sizable chunks. Having anonymous functions in this new language won't probably be too challenging to implement, but will be, the biggest challenge will just be deciding the syntax and things. JavaScript Monka S. Sorry, I'm not quite following that. What's Monka S? Monkas? So built-ins, and then I have this this built-in function that I'll be using for reflection and things. So yeah, let's take a yeah, I'm just thinking, do I already have some level of can I assign built-in functions to variables? I think I can, but I must take a look at that sometime. Oh, sorry, yeah. Um, an emote. So yeah, I'm using what's it called, OBS for streaming. So I'm actually because even though I'm streaming to Twitch, I'm not actually using Twitch locally. So I can only see the bare minimum of emotes. Sorry, forgive my ignorance, please. So yeah, so I think I'm going to just go ahead and jump into definition of objects in this language. So I'm going to start off with object literals. Yeah, and we'll see how that goes. So let's see. It's been a while since I opened up the parser file actually. So this is going to go into the expression section. So here is a definition, I believe, of that's index access. Oh yeah, and there's list list literal. So I'll probably want to put it somewhere around there. Is going to be object literals. Whoops. There we go. And this is going to be not an expression list, I suppose, a field list. And call that fields. And that's going to create an object expression with fields. And that'll be then in the AST. Let's see. Or will I call them props to to be more in line with the JavaScript terminology, but then how many languages use properties as the name for this? So they're usually called properties or fields, I think, aren't they? What does Python call them? Python. Attributes probably. Oh, sorry, yeah. Attributes, and yeah, a lot of languages call them attributes as well. Yeah, I'll just call them. Yeah, I suppose since I'll be borrowing a lot of, I can always change the terminology later, but because I am borrowing a lot of the functionality of objects from JavaScript, probably just call them props for the moment. And again, basically just a research language, so this isn't going to be the final language itself. So not all of these design decisions are going to have long-lasting consequences, I hope. So we'll just go with this for the time being. So instead of an expression list, there is then going to be a prop list. And that'll be a vector of, well, this won't need to be a vector of list items. It would probably eventually want to be a hash map. But for the moment, it's probably, because the order isn't going to matter eventually. It shouldn't anyway. But for the moment, yeah, it's fine to store it in a a vector. So I'll get rid of those unspread operators. They could be coming back later on, but it's all right for now. So then a list item will create something similar. And in fact, this doesn't need to be a prop item. This can just be a prop. Whoops. And let me think. So clearly it'll have a name, which will be a string, and it'll have a value, which will be an expression. Is that the dealio for now? Yeah, I think so. And yeah, so for the moment, I'll probably do it old school JavaScript style, where the name has to be a string literal. Oops. And then that will be followed by just a colon. How do I make sure? Oh yeah. And then it'll be followed by an expression. So that will be and that will result in a prop with name and expression. And then up here, I'll grab head and tail. So the property is just going to go in there. And then in the case of a head and tail, clone the tail, insert the head at the start and return the list. And that could be more or less it for implementing a very basic implementation of an object, literal anyway. So what are the issues that we're encountering? Expected list item, yeah, don't think that's correct. And oh yes, that should be value. Okay, so yeah, we just need to be able to handle that in the evaluator then. And that will also mean that we need to add a new value type for that. So an object then is going to be so we'll actually use hash map here, be a hash map from a string to a valref. And then we need to actually add some handling for that. So then on line 402 is where we probably want to start. So if we encounter an object expression, and what will we want to do in there? Yeah, we'll just want to build up a new object value. So that'll be okay, a new val ref, and can probably, there's probably a very clever way of turning this oh wait, no, so I'll still need to go through each of these properties and evaluate them one by one. So let's see. In fact, I can use a lot of what I've developed for the list evaluation, except instead of doing a vals push, I'll be doing a this will be a hash map string valref new. I think that's the syntax. Yeah, I'll just leave the name the way it is. For item, for prop in props, evaluate the expression. Yeah, if so, can ignore that. And then it gets the oh yeah, so this is if it's not a spread, then it just adds it, and if it is a spread, then it modifies the or checks what the incoming value is. So in that case, spread isn't a thing here, so that should simplify things enormously. So I'll go, is it add, I'm guessing. So the prop value is going to go there, and then the prop name is going to go here, and value is going to go there. And then we'll turn it into a new value object with the new values. So let's see what's going wrong here now. 506, we're getting a compilation error first. And okay, yeah, I thought there was a syntax issue there. So is it set, push, oops. No, I think I used it in main. Insert, yeah, that makes sense. Okay, cannot move out of prop name, so maybe I can get a reference. Nope. So maybe I'll have to clone it. If I clones it around the place, I'll have to sort those out at some point. But let's see. Non-exhaustive pattern on line 240 then. So if there's a bind, yes, and so if oh, I committed some code, some silly comments. Oh well. Anyway, so at the moment cannot bind to an object, but later on we will add support for object destructuring. And then cool, so we haven't actually added any test code for this just yet. So let's take a look. So I'll go, I'll just get rid of all of this. I'll create a new object. In this language at the moment, it's just using what do we call them? Single quotes for strings. And yeah, that seems to be basically what we would want from object literals. So yeah, that's nice. Yeah, so I'm just going to go ahead and commit that. That's I think a fine initial implementation of this functionality. It's not lightweight by any, or it's kind of not ergonomic just yet, but that is something that can be added later. Cool. So then what, so that's one thing off the to-do list anyway, but there are a couple other things to add, and maybe I won't even be kind of too concerned with the ergonomics in, again, this research language, but once the research language has been developed, I can take a look at what are kind of all of those kind of optimizations that we can use. So for the moment, what I'll do is I'll add that to the done column, and next I can work on index access and index assignment. So yeah, so index retrieval should be relatively straightforward. Boolean comparison operations. Yeah, maybe that's kind of redundant because they're they are the values that they are. However, Boolean comparison can actually be useful for well, I'm not sure if this is why you're getting at, Juan, about surprise at Boolean comparison operations, but you can use them for implementing, for example, is it XOR and XNOR are basically equivalent to equals and not equals. So while most of the time you'd be using Booleans for just for greater than and equal. Yeah, maybe I have that actually. Well, I think yeah, there'll be not equals as well. So that'll essentially be uh, x XOR. No, that'll be XOR, and that'll be XNOR effectively, I think. Yeah, I don't think I probably won't be doing greater than or equal to on Booleans. Maybe we'll see. Um, so let's take a look at the next one was index retrieval. So so that would be something like print x. And this is something that will probably be a source of a lot of playing around with, but we have our simple, again, a lot of this coming from JavaScript. There is, access using the index operator. Then we can also do what's it called? If the string is a simple string, for example, not containing any spaces or anything, then we can treat it like a field access. Could also potentially do something like this where it's distinct from index access so that we know that it's on a field, but then it can be used if the value for whatever reason has, say, white space or something like that. And then there's also a possibility that we could do, what else? This would probably be more unified then in terms of, looking more consistent with regular field access. Because one thing that does bug me about JavaScript is that you have kind of two ways of accessing a field, two ways of doing the same thing. One thing I was kind of thinking is that if you have a field that you can access using the shorthand, then you're not allowed to access it using the other mechanism. I don't know, that could be, there could be for and against there. One other thing then is if we had I suppose the one issue with this this approach then is that if you wanted to access something that's behind a variable, such as in the case of, so if X was that object and Y was B, then, this allows you to, access, or maybe I'll make that A. So these two accesses are the same, whereas you can't do this because it'll try to access the value at Y. So maybe you need that, unless, again, what I'm considering later, again, because this is going to be an alternative to Bash, there could potentially be a good reason for reintroducing the $sign. I don't love the $sign, but it could be useful for making some other operations more ergonomic. So there's a lot of stuff to play around with, but again, at the moment, what I'll do is I'm just going to focus on the simplest approach possible. Nim doesn't have shortcuts, is it, Juan? Or what doesn't Nim have, sorry? Oops, wrong eval file, that's a backup. And get my test script up there. Yeah, so then now one thing about this, having a shared syntax for the index operator means that that operator is now overloaded. In fact, I might add that to the to-do list of R&D. Consider not overloading operator. And there is, so the next bit I would have done is, take a look at the parser. Don't think anything will actually need to change with the parser now because of the way it's currently written. So I might actually change just the name of the item that's being nim won't have not equals, greater than or equals, or comparison. Okay. For which? For booleans, is it? Okay. Yeah, I suppose it wouldn't, like, it. Oh, for anything. How do you do comparisons? It's not equals is transformed to not equals AB. Okay. Okay, interesting. So it kind of cuts out half the number of operators. That's interesting. Um, and is that kind of for the sake of having one kind of one way of doing things again, kind of similar to Python? So I'm just going to rename that here to be a little more. So it still won't necessarily be an index in the object, but the terminology will be slightly more appropriate. And in fact, is in the parser, it's just being it's just an expression being added there, isn't it? Yeah, that's just an expression. So where's index? Maybe I'll call it at. Possibly a bad name, but it's probably more it's probably more generic over the type of or maybe position or place or location. Yeah, we'll go with that for the moment anyway. Yeah, it simplifies things. I get it. Yeah, makes sense. So then next thing to do is to add support for that with objects. So if I evaluate then an index operation and it isn't, so at the moment we only support that on lists, but now I'm going to support it on objects. And so we're going to say can only index lists and objects. And so we're going to evaluate the so this is not going to be n anymore, it's going to be location. In the case of a list, it'll still have to be a location, but in the case of an object access, this is going to have to be a string, str, and I think that needs to be s. And in this case, so index must be an integer, index must be a string. Could change the terminology to be key in this case, or property name. And so in this case, we're going to have props, and this is going to be, oh, this is, whoops, this is index assignment. Whoops, no, this isn't what I want to change just yet. Should be more straightforward than I thought, actually, potentially, especially since, you know, went through a lot of hoops to get it working with indexes, so should be able to capitalize on that when working with objects. But no, what I want to work with at the moment is just retrieval right now. So index location, and if it's a list, then we'll do that. But then if it's an object with props, we're going to do expect a string here. Can only index lists and objects. And prop name. Nim also doesn't have foo or foo indexing or index assignment. It also simplified out. Okay, it doesn't have indexing. So like do list indexing via functions, is it? Or how does that all work? Oh, is that part of that? I think I was looking it up since last time, that universal kind of call syntax. So property name not found. All operators are functions. Okay, yeah, that makes sense. Like, that makes sense from a point of view of kind of trying something new and kind of working. Would be interesting to try that out. I know one big benefit of just kind of functions over operators and things like that is just the fact that I think in general they're easier to search for. But yeah, no, it does sound very interesting. I still haven't looked too much into it. I've only had the briefest of looks, but no, like certainly seems to be trying out a lot of new ideas, which is very cool. So property name must be a string. And so then with that all done, that should more or less be it, I think. Eval 257, yeah, there's probably a few areas where I need to update n to be location. And then, yeah, in the parser, even though the output is somewhat unhelpful in this case, but I will forgive it because I'm doing something silly. And then, so let's see, yeah, so in the next line then we have accessing property A. And similarly, if we put in there xy, should get output 1 as well. Yeah, nice one. So that's working as expected. What else do we want to do? Yeah, just to mess around a bit, maybe see what happens when we try to index it by 1. Property to n must be a string. Yeah, makes sense. Nice one. Cool. So in that case, yeah, I suppose I'll add that as a new bit of functionality. Oh, I'll just add some, just change some formatting. I think, or or did I? Value list. Oh, I did remove that that new line, so that's all right. So I'll continue adding, and I'll remove that bit of test data from the end just for the commit. Yeah, and oops, maybe I'll actually remove that as well, just so we're not committing an error. Git add p, yeah, and add support for object index retrieval. Yeah, or that should be probably property retrieval. Yes. Cool. So that's another one ticked off the to-do list. Let's maybe try assignment. Where are we now? Object index retrieval and then index assignment. But that's an interesting idea of the yeah, not having operators as such, just having functions for everything. I suppose one of the another benefit of that being that you don't have to wrap things in closures in anonymous functions in order to turn them into functions. Everything is just a function already. So all those operators are kind of ready to use as functions. Could be a neat idea. Yeah. Anyway, getting back to index assignment, let's take a look at this. So if I go back into my test and I say x, y is equal to b, and then I print x again. First of all, I'm going to get an error here because we can't assign, yeah, can't index non-list. Actually, that will that is something that needs to be can only assign to indices of lists and objects. Okay, and then we're going to basically do the same as below, where this is then going to be props. Although will I need to oh, I already have a lock on prop. I don't have a lock on props. Could this be a bit trickier? So what's happening in here? So I get an index operation. I evaluate the left-hand side of the expression. So I called that x's before, but that can this can now be that was just a bad name. This this is an equally bad name, but at least it's clear that it's not necessarily a property, or sorry, it's not necessarily a list. So in this case, so I do have a lock on value, and that means I have a lock on props. Okay. And then, so that means that I can do a put here. Wait, what am I doing? I can do a put here of S, and let's see. Can put, oh yeah, the right hand side. And it doesn't matter in this case if we, so actually one thing that this isn't handling is out of bounds access. And that's also not being handled below as well, I'm assuming. So if I go to index assignment, yeah, no, it's being handled down there, but not up here. Whereas in this case, you know, there are no bounds to a hash map as such. So, and I need to use the actual method here. Expected that kind of a string, but got this kind of a string, so I need to change the type of string that I am using. And all right, so in fact, will I test? So can I print a new line like this actually? Probably not. It'll probably actually print a literal string containing n. Yeah, there we go. That doesn't print a new line just yet, but we'll get there eventually. So let's see, does this mutation work? So I assigned b to y, and that didn't overwrite the value. That's very interesting. I have to explore that more. One other thing to try. Oh wait. Oh no, I assigned it to A, sorry. So A got assigned, or B got assigned to A, and so that that did work. Whew. Nice one. And then if I tried doing, let's see, what's the next one? An out of bounds assignment. Will that work? Should do. Don't see any reason why not. B, C, D is then assigned to D. Very nice, cool. And that was a lot less painful than when working with assigning to indexes with lists, because none of those kind of value references had been implemented at that time. So yeah, got to piggyback off of that effort. So then, so that's meaning, yeah, kind of breezing through implementation of objects here. Assignment. Oh no. Oh no, I didn't mean to amend that. That's a separate thing. No, didn't mean to do that. Can I do a... okay, first I'm going to check out a branch just to make sure that it is a backup, and then I'll go back to where I was, and then I'll check yeah, I'll check the reflog. So I changed branches. I did an amended an amended, whatchamacallit, an amended change. So let's see. So there does seem to be a commit from before for the amend. So let's take a look at that. No, that's 7.5. Can I just do head at 3? So if I take a look at the git diff between no, in fact, I'll go back to my, what's my best way? Oh, if I want to keep it by creating a branch, now I won't bother. So let's see, reflog, and then I can see the thing that I want. Can I do a cherry pick possibly? And then amend that onto cherry picks. It's now head at 5. And what's the status of this thing then? So if I get this and I jump to, so this was in the newest change, so, and that was in the newest change. So that could be, whoops, what's happening here? It didn't undo. Oh, sorry, it did. Or it attempted to. So, yes, I think I've gone back in time. And so so this is going to be committed on top of the last change, but I want to replace the last change with it. In fact, oh no, what's my best bet here? Okay, yeah, sorry. So I'll git cherry pick abort, and then what's my git log looking like? Yeah, I just did that property assignment thing. So I'll git reset. Ooh, risky business. Git reset hard head. Git reflog. Git cherry pick head at 6 to get my support for property retrieval, and just to make sure that I still have so it was first object literals and then object property retrieval. Yeah, so there's that. And if I check this file, it should be the same. And if I check eval, it should be the same as well. If I look for index, it's not implemented for bind. And if I search again, it is implemented for retrieval. Yes, so that's what I wanted. And then I want to I want to do a merge fast forward with is it fast forward only with the backup branch, I think. No, maybe I'll just cherry pick that as well. And let's see what happened here. Yeah, just added the new stuff. and then I need to do the same, I assume, in test.txt. Yeah, and that's got all my new stuff now. So then I'll, oh yeah, can't do a thing like that. I just need to do git commit, no verify. Oh yeah, I need to actually add all of those things. Oh no, I didn't need to add the test for. And yeah, that has to be no verify. Add support for property assignment. And then if I go to my git log, add support for literals, property retrieval, and property assignment. Whew. Big load of work for something that really doesn't matter too much, but yeah, I wouldn't be obsessive if I wasn't doing this stuff. So that's then, yeah, that's probably that done. So that's assignment done. Then next thing to do, yeah, brilliant. That's a nice number of things knocked off today's list anyway. And object composition. So I suppose there's so that'll be a nice thing for data structuring, so that if we in fact, if I work in my test file and I'll comment out a bunch of these, and so if I want to do some some composition, where's my Z character? There we go. So I can do a spread there. Okay, so reintroducing the spread operator for objects. And what was, oh yeah, we might need the unspread operator for destructuring as well. So so let's see. So if I have D, and that'll be 4. So how do I make sure that it's that things are happening in the right order? So this will unspread X into Z, so I'll get all those properties first. And then if I say B is going to be 5, that should override the value from X. And then if I do the same, if I call that Y, and then if I do the same with X coming later, then this should all hopefully work as expected. So this will overwrite the B that came earlier, but in this case B will be 5. In Z, B will be 2. At least that's the intention anyway, but none of this actually works because I haven't implemented the unspread operator for objects. So yeah, looking at, what's it, 1/4 to the hour at the moment, so might be able to get this done. Again, a lot of this already, the groundwork has already been laid by whatchamacallit, by the list functionality. So so hopefully we'll be able to just reuse all of that. So, so do I want to modify the definition of a prop, I suppose? I'll create a new prop item thing for the AST maybe. Or maybe I'll just modify what I have here. Whoops, and that should be there. Yeah, and because I'm creating yeah, so maybe because I have a specific kind of type for handling props here. Whoops, where'd that go? Prop item. Yeah, so I'm just going to embed the how do I split it when it's on multiple lines? I go on to the next line and I indent it. So so let's see. Yeah, I'll just embed the handling of spread in there. So that'll be less work for me then. Is spread and or maybe I'll do it like that, maybe. And so that is then support added for the syntax, at least, I think. Yeah, I still haven't, so I did rename this. So props will need to be, oh, what did I do there? I don't even know how I did that. So props will need to be renamed to prop items. But where? Let me see. Oh, just in the AST 39. And actually, that helps now that it's being stored in a vector. After all, I'm glad I didn't set that up as a hash map, because I would be going back to, because this is, I am just kind of hopping all over the place with the, oh, I keep closing tabs. So I'll go back to AST, but yeah, the matter does order here because I'll be overriding field values in the order that they were declared. So in that case, unrecognized token, did I have, maybe I'm missing a, I would have thought the unrecognized token issue would be gone by this point, since I, did I have 2 dots for spread and unspread, perhaps? Oh, I did know. Oh, taking a bit of time for that compile. Let's take a look at the parser then. Yeah, so unspread is using, or spread is using 2 dots. And we don't have evaluation support yet for it, but it shouldn't be resulting in a syntax error still. And this is location 51. So massive hack here. Let's just, again, still don't have everything, still don't have the errors rendering very nicely. So I'm just gonna manually see where this error is. So character 41. So on that X, what's wrong with that X? Unrecognized token. Oh, it's because at the moment I'm saying that it would have to be like this. Yeah, that was very silly of me. So I'm gonna have to change that up a bit. So a prop item can either be a name, which again, no, in this case, it can be an expression, I think, followed by a spread. Or it can be a name value pair. But how are things going to work? Nim simplifies KV and KV. I'm not sure I follow there. Like adding the same key value pair twice. So I'm going to allow a spread here. Is it going to allow a function here? Can you do an unspread of any expression? I'm guessing so. I might actually just check Mozilla, or is it MDN? Values. So what would this be called? This would be called object composition, maybe. Okay, interesting link. I'll take a look at that later. But yeah, Nim certainly has a lot of features, it seems. So so let's see, and maybe MDN. JS assign maybe, or maybe destructuring assignment actually. So that's destructuring assignment, all right, but I'm more interested in almost like destructuring during composition. Okay, maybe, yeah, maybe this covers it as well. Or maybe it doesn't. No, I don't think the inheritance is what I'm looking for. This is basically what I'm looking for, I think, but it's the built-in syntax for it, which is probably going to be referenced here, I would assume. Spread in object literals. Yes, this is what I believe I'm looking for. So, whoops. Okay, so, oh, you do the three dots before the object to spread it. Okay, interesting. I think I'm going to stick with having it after the object. Does it say from a provided object into a new object? In fact, can I try out this stuff? So if I go into the console here and I say, oops, if I say, for example, let x equals a1 b2, and then let y equals or if I go let f is equal to just return x, and then if I say let y equal, or I don't even need to do it, let y, I'm going to check 1, 2, 3 f. What does that evaluate to? Okay, yeah, so you can actually have an expression in here. That makes sense. So in that case, let's see. Yeah, so we're going to allow expressions in there. So yeah, that's been validated. So there's we check if there's well, if there's an expression here, then there has to be a spread here. And in this case, let's see, in the AST, an object, so a prop item is actually going to be an enum, which can either be a pair or it can be a spread. And in the case of a spread, it'll be taking an expression. So and so that should hopefully work. Okay, so what's that messing up in the evaluation? 541. Oops. Yes, yeah, that's what we'd expect. And 456, yeah, that's all right. So matching on the property type. If it's a, what were the two types? Prop item pair, and it's a name and value. Then we do that. Yeah, and if it's a spread, then I'll have to evaluate it and then spread out the values. And in fact, I'll just ignore that for the time being. Does this work now? Yeah, so that so spreads just aren't working now, but I think the in fact I might update main to do a pretty print of the debugged object. I think it's the pound symbol. And yeah, and so we end up with DMB. Yeah, it's just ignoring the extra fields. So let's go ahead and can I get rid of that clone actually now that it's, well, it's not a different variable, is it? It's still the same variable. So what I'll have to do then is evaluate this new expression, and I'll have to go through all the pairs in that and insert them into vals. So that'll give me back a val ref, so I'll need to lock it, pop it and lock it, and go through yeah, so first of all that'll need to be an object. Just checking the syntax that I've been using for the other ones. Yeah, it'll depend on what I'm wanting to do with it, so I'll just leave that out for the time being. And so then this has to be an object value, or else I'm going to kick up a fuss. And say can only spread object in object. So then once we've determined that it's an object and those are the props, then we're going to loop over those, prop in props, and ooh, is that even, yeah, I think that's possible. So in this case, I'm going to do hash map Rust iterator. And I'll just assume that that does what I want for the time being. And so I'd be doing a vals insert prop name again, yeah, clone, and yeah, that'll probably be relatively straightforward. So into iter, although I probably won't want to do, I probably just want to be an iter. And how do I access the values then? I can just do key value. Ooh, errors. Oh, thanks, Juan. Thanks for tuning in. Have a good evening. So then the expression is type mutex guard. Yeah, so we need to do as before and get that out of the guard. Next is line 560. Need to convert that to that. Expect an arc but found a reference. Can I do it? A clone of the arc? Do I want to do that in this scenario? Yes, I think I do. One thing that I've just realized that could be interesting, I wonder, can I overwrite the value in boxes? So I'm actually going to, just for the moment, something has just come to my attention. And I'm going to comment out these. Let's see. So if I have x is equal to a, and I say y d is equal to x a, and then I say yd is equal to 2, whoops, and then I print x, what am I going to get? Okay, no, that's safe. No, just making sure that I wasn't doing something silly, basically. So let's try this new setup. And prop name clone. Where is that happening? 569. Yeah, that doesn't need to be done anymore. Data moved here. So I'll need to do that perhaps. Okay, and so yeah, so there's some output anyway. Let's take a look. Why is that in a list again? Is it because the parameters are being passed in an argument list? Not sure. Must yeah, it probably is. So let's take a look at the test that is happening right now. So basically in this instance, the second instance, so we want A to be 1, B to be 5, C to be 3, and D to be 4. So the main thing is D should be 4 and B should be 5. and D is 4 and B is 5. Yeah, nice one. And then in the final output, we want B to be 2 and D to be 4, and same the regular values for A and C. So A is 1, B is 2, yeah, nice. C is 3 and D is 4. Brilliant. So that is then object object composition using the spread operator. So yeah, time to add a commit for that, but not an amend commit. Add support for, oh yeah, didn't actually add any of these changes. Nice. So I'll git commit that, and that would be mute. Yeah, add support for objects and composition spread. Cool. And with that, that's just about everything to do with objects implemented. So that's not bad for a day's work. I suppose I could put this under objects as well, is so there's object destructuring. Is there an unspread destructuring for objects, such as, so if I go a b is equal to x, yes, so any fields that weren't used up here will get put into b. Yeah, I think that makes sense. So I'll just put that as a reminder to myself. So I'll take that out of or no, maybe I'll leave it in there, even though it's in two places now, but that's okay. Cool. So that's oh, and I think, yeah, that was basically again duplicated, but yeah, not bad for a day's work. So not much left in objects. Just destructuring. Then I'll want to add some kind of syntax for anonymous functions. Again, most functions are mostly implemented, so adding a syntax for that for anonymous functions shouldn't be too difficult. And yeah, a lot of the rest should be relatively straightforward, like having the type function for reflection would be useful. But that is more or less, yeah, that's it for today anyway. But quite steadily approaching the kind of almost end of this the end of the implementation of this research language anyway, and we'll probably be coming up to a time where I start implementing uh, the kind of language that is going to be making use of this. So anyway, thanks for checking the stream out, everyone, and yeah, see you next week.